Okay, now that that's out of my system. Okay, so it says in Unit 1, we solved inequalities of polynomial and rational functions. Do y'all remember doing this? Inequalities. So we're trying to find where on this rational function does f of x be less than 0. Y'all remember? And we would run like a sign chart thing, and we would name the zeros. This is a place where x equals 0, whatever. And then we would test positive, negative, it makes a negative, and a positive, positive makes a positive. Y'all remember doing this before? Okay, this is that. This is that with trig. Okay, so gear up. Let's get ready for this. It says, in the past we did that. Similarly, we can solve inequalities involving trig functions. This is in the second half of your 3.10 notes. Example 1 says the graph of f is defined for negative 2 pi to 2 pi. What are all the values of x for which f of x is less than or equal to 0? So if I were looking at this function and I want to know where is y less than or equal to 0, I would say that's going to happen on an interval from negative pi to 0. So they want it in interval notation like this. Negative pi is less than or equal to x is less than or equal to 0. Alternatively, you could go negative pi to 0 with closed brackets. And where else? On this particular interval, huh?
Pi to negative 2.
Pi to 2 pi?
Yeah, whatever.
What he meant.
It's all the same thing.
It's all the same thing, yeah, sometimes. So from pi to 2 pi. Okay, so that's really graphically what we're finding. And in fact, when I did your homework today, that's how I checked mine. I graphed it. And in Desmos, let me say this. In Desmos, it's beautiful because they pop up your picture, like if you graph it on your phone in Desmos, and then you hit the graph, it pops up the x-intercepts at their actual exact value. So you can see at pi over 3, that's a 0. At 7 pi over 6, that's a 0. And it writes them in perfectly beautiful exact values like that. So hint, hint. When you want to check your sign chart and you want to check your intervals of increasing, decreasing, or positive, negative, Desmos is beautiful.
Can you do it on the calculator?
Yeah, you could. But you probably are going to have to convert. Like if it says it goes up through the x-axis at 6.28, you got to know that's 2 pi. Does that make sense? So you could do that. Solving inequalities is easy when we're given a graph, if only all problems were so simple. However, we must also understand how to solve inequalities in analytical form or in algebraic form. For simpler inequalities, that only involve trigonometric expression, one trigonometric expression, we can use our understanding of unit circle. Okay, Truett, you're about to kill this. You like this, promise. It says, using the figure, what's the solution to the inequality where sine theta, so this is my y value, is greater than or equal to square root 2 over 2? So where are my sine values greater than or equal to square root 2 over 2? Pi over 4 to what? Pi over 4 to 3 pi over 4. So you can't see this, but it's been highlighted here.
Yeah, it's bolded.
It's bolded?
Yeah.
Okay, so we're talking on the interval, and it says greater than or equal to. So the answer here is going to be pi over 4 is less than or equal to x, which would be less than or equal to 3 pi over 4. That's the interval for where my sine value, my y value, is taller than or greater than. So if I could make like a rectangle out of this deal whose height is square root 2 over 2, then up here above that rectangle, you can tell it's taller than that. Is that making sense to y'all? Mm-hmm. Okay. These are nice and unit circle-y and pretty. Let's try on the next page. Example 4, it says, let h of x be 3 cosine x. Sorry, that's example 4. Lies. F of x equal 4 plus 2 cosine x, and g of x is 3. What are all of the values on 0 to 2 pi for which f of x is less than g of x? So we're going to set them not equal to one another. Set f of x less than g of x, and let's go to solving here. So we'll subtract the 4. 2 cosine of x, I lost my x. 2 cosine of x must be less than negative 1. Bless you. Divide by 2. Cosine of x needs to be less than negative 1/2, which means
that's a small interval.
To the left of negative 1/2. And Truett's saying it's a short, right? A negative short. So our shorts happen at 2 pi over 3 and 5 pi over 3. And we actually want to contain the parts of this circle that are outside of that to the left over here, because we need to be less than. Does that make sense? Less than negative 1/2. So that way, from negative 1/2 to the left of that. So our interval needs to go from 2 pi over 3 less than, not or equal to, not equal to, just less than. 2 pi over 3 less than x, which is less than, what's the greatest value where this happens? It's 4 pi over 3. I wrote it wrong. It's 4 pi over 3. Are you able to visualize it a little bit? Jenna? Not so much? No? Okay, so example 4, it says let h of x be greater than k of x. So we've got 3 cosine of x greater than square root 3 plus cosine of x. He said, do we have to factor? No, not on this one, because there's no squareds. It's not quadratic.
But if you subtract cosine, you get 0 cosine.
I can take away. If I've got 3 piggies minus 1 piggy, how many piggies I got?
Oh, see, I divided it by 3.
2 piggies. 2 cosine x is greater than square root 3. Divide by 2. So we're looking for cosine of x to be greater than square root 3 over 2. So this is a long. Cosine's a long. Pi over 6 and 11 pi over 6. Good, because this is where cosine's positive. So really from pi over 6 to 11 pi over 6, but I'm on an interval from 0 to 2 pi. So it's very hard to show that, except that I have to break it into pieces.
Could you, question,
Okay?
could you say from negative pi over 6 is greater than...
From negative pi over 6 to pi over 6, except that that doesn't fit in this interval from 0 to 2 pi. I see what you're saying, and you're right about which portion of the circle. So the question was, could I go from negative pi over 6 to positive pi over 6, but not within 0 to 2 pi.
Is negative smaller than 0?
So on 0 to 2 pi, we have to go from 0 to pi over 6, and then 11 pi over 6 to 2 pi. Good question. And also these are not equal to. Who can tell me why? Because what's the inequality that we started with? H of x greater than k of x, not greater than or equal to. Okay. I was looking back at this domain to see my signs, and that's not right. You got to look at your inequality. Capiche? Okay. To the next. Okay, so out of this information, how to solve trigonometric inequalities. I really liked step 1. Set f of x equal to 0, solve for x. That tells me what numbers to put on my sign chart. I didn't so much like the rest of them. Number 2 says create a sign chart. I got that. Number 3 says test a value in one of the intervals by plugging it back into the factored expression. I liked that. Then it says it's usually easiest to pick a value on one of the axes if possible. Yeah, because I want to plug in a 0 if I can, right? And at pi over 2, sine is 1 and cosine 0. At 3 pi over 2, I've got the same kind of setup. That's nice. The quadrantal angles are good for you. Here's where I got into trouble. It says, remember the signs will alternate. I didn't find that to be true. So you need to test every interval, okay? I don't know if I did it wrong. I don't know if that tip was just I read it wrong or what, but I did not get positive, negative, positive, negative. It wasn't true for me. So beware.
Would it be positive, negative, negative, positive?
Maybe. And maybe that's how it was supposed to, like, maybe. But I didn't benefit from that one. I would test. Okay, so let's jump into example 5. We've got about 10 minutes. Y'all, we've got this. It's going to be great. All right, example 5 says, what are all the values on 0 to 2 pi for which 2 sine squared theta plus sine squared theta is less than 0? Okay, so this is sine squared and sine. You can pull out one of the sines, right? Sine squared. So I'm going to be sine theta on the outside and 2 sine theta plus 1 on the inside. Yeah? Set them equal to 0 and solve, and this is going to give us our numbers for our sine chart. So set each piece equal to 0. When is sine of theta equal to 0? When theta equals 0 or pi or 2 pi. We can include all three because we're on the interval including 0 and 2 pi. Okay. The other one says 2 sine theta plus 1 equals 0. Swing the 1. 2 sine theta equals negative 1. No, we pulled out the sign. We don't have any squareds anymore. So sine theta equals negative 1/2.
So,
7 pi over 6 and 11 pi over 6. Y'all want to play the unit circle game again? I think y'all would kill that. Okay, so on my sine chart, what comes first? 0, and then out of these 5 options, what's next? Pi, and then 7 pi over 6, and then 11 pi over 6, and then 2 pi. And this is where it gets tricky. Plugging in a number. What are we going to plug into? We want to plug into this most easily factored one right here. Okay? So on the interval from 0 to pi, sine is positive. So this first piece, sine of whatever, is positive. Let's plug in something nice between 0 and pi. Let's plug in pi over 2. Sine of pi over 2 is 1. So I get 2 times 1, which is plus 1, positive. So on the interval between 0 and pi, we're positive. So we plugged in pi over 2. Sine of pi over 2 is positive. So that's my first positive number. And then 2 times sine of pi over 2. What is sine of pi over 2? 1, right? So 2 times 1 is 2, plus another 1 is positive 3. So we have a positive times a positive, so on that interval, we're positive. Kind of see what's happening here? Now we want to pick a number between pi and 7 pi over 6. Okay? We know that at 7 pi over 6, the sine value is half. So a number that's a little bit smaller than half would be a fourth. Y'all with me? But it's a negative fourth. Sine of whatever, that's going to be a negative number on the first piece. And if I put a negative fourth in place of sine theta, I've got 2 times a negative fourth, which is a negative half, plus 1. Negative 1/2 plus 1. Negative 1/2 plus 1. Positive. So that interval is going to come out negative. Now pick a value between 7 pi over 6 and 11 pi over 6. Yes, ma'am, I picked it. 3 pi over 2. What is sine of 3 pi over 2? Negative. So my first one's negative. Negative 1. When I plug in here, negative 1 times 2 plus 1. Still negative. Not enough to come out. So positive. Pick a number between 11 pi over 6 and 2 pi. Well, I want sine of that number. So I'm going to call it a quarter. Right? Because sine of 11 pi over 6 is negative 1/2. I want some number between negative 1/2 and 0. Pick negative a quarter. Okay, so that's negative for sine theta. Put a negative quarter in here for sine. Multiply it by 2. That's negative 1/2 plus 1, positive. Y'all see? It does. This one does go positive, negative, positive, negative. Right. And so we're looking for times when this is less than 0. So our answer is going to be pi and not equal to. Pi is less than x is less than 7 pi over 6. And 11 pi over 6 is less than x is less than 2 pi. And I actually think on these they use the letter theta.
You know what it could have been? The problem we were working with B was probably greater than 0. So it was stretched and the period was doubled. So it's going positive, positive, negative, negative, positive. You said it was positive, negative.
I don't know. Okay, here's what I did on the last one. Do you see that it's 2 cosine squared theta plus cosine squared minus 1? I swapped that out and let cosine be x. Okay, so I did a little substitution. I said this, let x equal cosine theta. And I rewrote it as a quadratic. This is going to be 2x squared plus x minus 1 equals 0. And I can factor that guy all day long. And I got rid of the cosines for a minute. You see what I'm saying? There's a little substitute a variable there. Multiply a times c. That's 2 times negative 1. That's going to be negative 2. Factors of negative 2 that make a 1 in the middle. Positive 2 and negative 1. So I'm going to have 2x squared plus 2x minus x minus 1. That's that busting that up into those two options. Remembering? What's next?
When you do 2x, so equal 2x and equal negative 2x minus 1.
So I've got 2x minus 1 and x plus 1. These are equal to 0. Go back to cosine. Or solve it for x and then go back to cosine because x is equal to cosine. So if you wanted to do that, you would have 2x equals 1. X is 1/2. So that's going to be cosine theta is half. And x equals negative 1 or cosine theta equals negative 1. What's the purpose of setting it equal to 0? What are we doing here? Finding our zeros that we're going to put on our sign chart. So my zeros, when is cosine equal to half? Positive 1/2. Pi over 3 and 2 pi over 3. Okay. When does cosine equal negative 1? Pi. Man, don't ever let anybody tell you you can't do stuff. Y'all are awesome.
Yeah.
Oh, not 2 pi over 3. Okay, so pi over 3, 2, 3, 4, 5 pi over 3. Is that right?
Yeah.
5 pi over 3. Okay, so those are the numbers that go on my handy dandy sign chart. From 0, what's first? Pi over 3,
Yeah.
and then pi, and then 5 pi over 3, and then 2 pi. And we're plugging back into our factored form, which would say 2 cosine theta minus 1 times cosine theta plus 1. That's what we're plugging into. What is cosine of pi over 3? Pi over 3 is a half.
Yep.
So we want something smaller than that. Call it a fourth. I mean, let it be easy. Plug in a fourth. So 2 times a fourth. A half minus 1. Negative. Negative. And that quarter plus 1. Positive. So on this first interval, we come out negative. Okay, between pi over 3 and pi, a pi over 2. That's the best, right? Cosine of pi over 2 is 0. So 0 minus 1 is negative. 0 plus 1 is positive. Still negative here. On my first one, I think we should have gotten a positive and a positive. So what happened? 2 times cosine of theta, which is going to be less than half. So I let that be a quarter. 2 times a quarter is half minus 1. Huh. I feel like mine came out positive right there. I don't know. Let's keep going. Let's see what happens. From pi to 5 pi over 3, pi to 5 pi over 3, we got a 3 pi over 2. Cosine there is also 0. So 0 minus 1 is negative. 0 plus 1 is positive. Get a negative. Let's try this last interval and see if we can't clean that up a little bit. So between 5 pi over 3 is 11 pi over 6, which is a half.
No, because that'd be 7 pi over 4.
11 pi over 6. You could plug that in, right? 11 pi over 6 is between 5 pi over 3 and 2 pi. No? Yes? 2 times. Wait. At 11 pi over 6, it's square root 3 over 2.
Yeah.
So you'd have square root 3 minus 1. What is square root 3? Off the top of your head. Anybody? I don't know. Somebody type that in. Square root 3.
It's going to be positive.
Is it?
Yeah. Because, I mean, square root 3
One, so it's positive, and the second one is positive. I think we have a mistake here in the first interval. It should have been positive, positive. Something we plugged in got just a little bit wonky. Anyways, that's the right answer on the last one. So if we're looking for times when it's greater than or equal to 0, we would have from 0, just trying to wrap up this video so I can post it, 0 to pi over 3, and 5 pi over 3 to 2 pi. Y'all agree with that?
Yes.
Okay, double check on that first interval. We should have gotten positive, positive. Sorry that was so fast, y'all. Good job hanging in there. You're awesome. We'll see y'all. Attempt your homework before you come back. Okay, attempt it. I'd love to just be able to answer some questions that you might have.